We're going to begin Chapter 4, which focuses on polynomials. And in order to understand polynomials, you need to understand what an exponent is. And so here we're going to take a look at some basic definitions related to exponents and take a look at some sample problems involving exponents. So here we see we have an expression 4 to the 5th power. This is often referred to as a power, this little raised number here. The larger number is referred to as the base, and the 5 is referred to as a power or the exponent. And this is written in exponential form. And what 4 to the 5th power here really means, or really is the same as, is 4 being multiplied by itself a total of 5 times. So 4 to the 5th power is really 4 times 4 times 4 times 4 times 4. And obviously you could just take a calculator and multiply 4 times 4 times 4 times 4 times 4, but you have to keep track of how many 4's you have. So is there an easy way to find 4 to the 5th on your calculator? Well, most calculators have a little button that might look like this, a little caret button, and that means an exponent. So I'm going to go to Mission Control here, and I'm going to use a calculator that I've downloaded on my dashboard as a widget here, and I'm going to show you how to calculate. Let me clear this out. Well, let's see, clear that out. Let's do 4 to the 5th power. We'd have 4, and then here's our little exponent key, 4 to the 5th, and that equals 1024. So that's how you use the exponent key on this calculator widget that I have on my dashboard. And I'll be showing you guys how to download that calculator onto your MacBook Airs a little bit later in the week. Let's take a look at some other examples involving exponents. Here we're going to write each of these expressions in exponential form. An easier way to write 8 times 8 times 8 would be to say 8 to the 3rd power. And an easier way to say c times c times c times c times c times c times c would be c to the 7th power, since there are 7 c's being multiplied together. This third example, we see we have a -5 and a 4. And since the order we multiply a bunch of factors together doesn't matter, I can multiply the -5 and the 4 together. And then I'm going to count how many x's I have as factors. Here I can see I have 1, 2, 3 x's, so this is going to be x to the 3rd. Then I can see that there's 2 factors of y, so that's going to be y to the 2nd. And then we have z to the 1st. And since z is just to the 1st power, we don't even have to put a 1 on it. It's understood to be a power of 1 if there's no exponent there. We've talked about perimeter of rectangles. Talking about area of rectangles means multiplying the length times the width. So in this example, we'd have x times 2x, but an easier way to write the area for this would be to say 2x squared. Now, when we're working with exponents and parentheses, we need to be careful here. Notice this example has 5a in parentheses squared. Well, that really means 5a times 5a. So here we have, as I said, 5a times 5a, and that would be 25a squared. And the reason we have both the a and the 5 squared is because we have the a and the 5 in the parentheses, but here we have 5a squared, just the a is being squared. So this is just 5 times a times a. Notice it's not the 5 and the a that are being squared, but just the a. So let's take a look at a few other examples here. Here we have -5 squared. Now notice there's no parentheses. Order of operations would say that we do the exponent first, and then we're going to multiply by the -1. So this is going to give us -25. However, this one says take a -5 and square it. So -5 times -5, and this is going to be a +25. Okay, you need to be careful with this on your calculator as well. Let me show you here really quickly. If you take -5 and square it without parentheses, you have -25, but notice there are parentheses here. So if I was to type -5 parenthesis -5 right parenthesis and square it, that's going to give me, whoops, a different result. Let's see, there we go, +25. So that's consistent with what we just did here in our notes, that the calculator is consistent with what I've mentioned here. Here, notice that I have to use order of operations. I would actually add first. So I'd have 6, and then I'd have to square the 6, and that would give me 6 times 6, or 36. Here, notice we're squaring each of the numbers individually. So we'd have 2 squared, which would be 4, plus 4 squared, which would be 16. And so the answer to this one is 20. So notice that order of operations here really does matter. That summing two numbers and then squaring the result is different than squaring two numbers and then summing the result. So order of operations matters here. We'll take a look at question 9 as our class opener. If you want to actually do that yourself, then you'll be prepared when we look at that question tomorrow in class. Don't forget to do the short survey at tinyurl.